So welcome to everybody. I'm an e-learning developer here at Sauce Labs. I've been educating others about technology and writing code for over a decade, and I've launched Sauce School training with the aim to help make test automation accessible to all. This is going to be a presentation of beginning test automation. It's really designed for people who have limited to no experience with automated test code. What you're going to need to know, what we're covering today is also written down. So if you miss something, if you're not understanding something, you can follow along in the Selenium Java course. You can find the Selenium Java course at training.saucelabs.com. And if you go to the Selenium Java course, the content, and then Java module 2. So this one will set up our first test, add assertions using the IntelliJ IDE, Maven, Java programming language, and the JUnit 4 test framework. I recommend you take the practice quizzes in the Selenium Java course. Okay, so some housekeeping. Some of you might have had issues with the last course. I realized that there was a typo, and as stated, you need to often update the dependencies in your POM XML file. So if your POM XML isn't working, go to the module 1 of Java. And I believe it is 1.05, where you'll, at the very bottom, you'll find the POM XML file. This applies to both Mac and Windows users. Just update this code, copy it, put it into your POM XML file. You can just paste it over everything. And once it's in there, in order to get Maven to go and rebuild and grab all the plugins that you need, you'll want to go to File, Invalidate Caches, and Restart. Anytime you make any significant kind of change to your project structure, it's good to do that. If something's not working and you're not sure why, it's sort of the, is it plugged in? This is the, is it plugged in? You want to start it and restart it again, just to make sure everything's working right. And as you can see right here, and the course part, it's actually now it's re-indexing and probably installing some new dependencies for you. If it's still not working, you can go to this repository and just download a zip file of it. If you're going to download a zip file, it's actually a package with a lot of different sample code. You would have to open the package that is in Java, module 1. We're kind of starting off with 1.05 or 1.06. So the first topic tonight is test strategy, what makes a good test, and how to plan a testing strategy. And we'll talk about what that planning looks like a little bit later on. The first concept is atomic tests. Atomic as in it's one singular thing that is whole on its own. So you think of atomic as being one single entity that doesn't need anything else. It's contained in itself. Creating a test that are atomic in nature are good. You can run them in any order. You can take tests and you can run them as part of different suites. So oftentimes, if you're doing regression testing or you're doing smoke testing, you might run a different set of tests. If they're truly atomic, it doesn't matter if they're not grouped with other tests or anything else. You can run it as part of any suite. And it's easier to group them. It's easier to pull them out into groups and saying, I only want this subset of tests to run this time. And it makes it less flaky. And we'll talk a little bit more about what flaky means later on. But flaky is when you have something that passes sometimes, and sometimes it fails and you're not quite sure why. And there can be a lot of reasons for that. So a truly atomic test tests one single feature. We don't want to check the login and the selection of your items and the shopping cart in the same test. You want to think about, okay, what feature or business need are we testing? It needs to be one thing, and we're only testing that one thing. So if you want to test the checkout flow, you only want to test the checkout flow. You don't want to do the things before or after. And it makes it easier to separate later on. We'll talk a little bit about what autonomous means, but that means they're standalone. They can run on their own. It's also better because it gives you, when you're debugging and you're looking at what failed and passed, it gives you a good indication of what specific feature is broken. When this test fails, you know what's broken. You're more likely to know what's broken. A good atomic test will run every time. It doesn't have to pass, but it will at least run. So autonomous means that it doesn't require setup or the running of another test. And if you think about it, it kind of makes sense that you have tests that depend on others, right? If you're going through the Swag Labs app, the first thing you do is you log in. The second thing you do is you select items on the page. The third thing you do is go through the checkout flow. Sometimes people group 3 tests together. So you have your checkout test, and then you have your selecting item test, and then you have your shopping cart checkout, and they have to run right after one another, right? You have to do the login before you can do the third one. That's bad practice though, because let's say later on you just want to pull out the checkout test. It would depend on the others. So what you want to do is set up your data and your state within that test. Depending on how you do that, it might take a little bit longer, but it's worth it when it comes down to maintainability. So here's an example. We would want to create 3 separate tests for the login page, a separate test for when you're picking out different items to purchase, and then a third test for your checkout flow. Ideally, to get to this third point, you'd be able to pass all the data in. You'll already be logged in as the right user and have selected these for this test, and it would all happen in one place. With the right skills, if you know about API testing, you can send the correct data to get to a known state. E.g., when I'm here in the checkout cart, I know I'm checked in as, or I'm logged in as standard user, and that I've chosen Sauce Labs backpack and the fleece jacket. So you start at that known state, and that's where your test starts. If you don't know how to use API calls, that's okay. When you're starting out, just have your test say, all right, before I get to my assertion phase, before I get to the part where I'm actually checking, just set it up all within that same test. Doesn't mean you're checking the login flow. It just means you're going through it. You're not doing any assertions, just check that the login flow went correctly though. You're not checking till the end. Recently, Sauce Labs has acquired a company called API Fortress, and they talk a little bit about what is API testing and how is it done. So if you are interested in learning more about API testing, there's a great new video posted by Sauce Labs. Another important thing for making good maintainable test suites is create descriptive classes. And this is something I've actually struggled with when I'm doing tutorials to learn to watch other people create tests. I'm like, why are they calling this class this weird thing? But it's good to name your classes descriptively. My base test is the base for all my tests. My login page object is for the login page. So name it descriptively because that can be pulled in as part of the reporting data. It's more important to be descriptive than to have a concisely named test method. Again, a lot of the time the reporting will pull in this information, and you want to know when this test is failing, what is it? What is failing? It makes it easier for you to go back and do that later on. So if I get an error at hidden element loads, there's a hidden element that's not loading correctly. So it's very helpful to do that. So as you can see here, this is how it would show up on Sauce Labs. And I actually pulled in, okay, here's the test class name. It's in the test directory, dynamic loading. And then this is the name of the test. It makes it a lot easier to go in and debug. Real quick, I just wanted to talk about behavior-driven development, test-driven development. The long and short of it, the best tests are written when your QA team can collaborate with your product and development team. Now, this is probably pie in the sky, the best case scenario, but if you can be in there and a part of it as the functionality of your app is being planned, the better able you are to write good tests and tests that test what you want to test and not too much. So behavior-driven development is an agile practice. It's just a methodology for collaboration between the business people who are writing the business goals, developers, and testers. It's a way of bringing testers into the cycle of, okay, software development, this is the feature we're writing. You create a shared understanding of how the software should behave and therefore how it should be tested. And then it takes specs like you would see in product planning document and turn it into an acceptance test. So if one of your specs is our customers can log in to the page where they choose products, you would base your tests around what the important specs of the product are. One of the ways it's done is, I believe it's Gherkin. They use a given, when, then description. You say, given such and such condition, when such and such happens, then such and such will be the outcome. Another strategy used for planning tests is test-driven development. It's a little bit higher level. It's a little bit more abstract. When I read about it, it said developer writes tests before application code is written. I don't see how that would actually work until you know what elements you're actually creating. But the basic idea is keep it simple and you ain't going to need it. I think the big important thing in both of these is that you keep in mind that you're not writing a test for every single little feature and everything you can imagine happening in your app. You're writing tests for the things that are important to the product. Does this work? The less tests you can write and the more elegant and concise you can be with your tests, the easier it's going to be to maintain and debug them. We're going to talk about defining a test strategy, and this is all from Dave Hefner's book on Selenium. And then we're going to talk about using an IntelliJ and Maven to set up and run your first test. So there are some questions you can consider when you're planning, like, what do I want to test? What are we putting in our test suite? What is the business value? What generates revenue? What is the core functionality? What is the funnel? I have got a phone that no one tests against unless they have Sauce Labs. It's called a OnePlus 7 Pro. I can't tell you how many checkout flows I have gone through that are broken. One item in the form, I can't fill it out and I can't check out. So making sure that those things that are really important in terms of we're not getting customer drop off because we can't have them check out for our product. So, and finding what those important pieces and the steps in the funnel are. Step 2, what does usage data say? User analytics tools. Which pages and features are being used the most? Those are also things that you should plan to prioritize in your test suite. Question 3, I know Sauce Labs has all the browsers you could ever want, but when you're first creating a test suite, focus on the browsers and versions that are most likely used by your customers. Again, you probably have to sync up with product a little bit to find that data. Once you have your basic test created, it's easier to sort of tweak them for other browsers or operating systems later on. What are the risky bits? What's broken in the past? Talk to customer support. What are there a lot of issues or reports around? What features, browsers, like elements on the page, locators, and operating systems, all of those can help you determine, these are a real smoke test. These are the things that broke before. These are the things that are important. It might be a big laundry list. You can also kind of keep an automation backlog, prioritize what you can maintain and what you need, and then create a backlog of things that you would like to automate. What we're going to do today, first part of the demo, is set up your first test. Chrome driver. When you test in a browser, you have Selenium, which is the automation commands, but there needs to be a middleman, a driver. Today, we're going to be using Chrome because it works on all operating systems, but Chrome driver is what helps Selenium actually drive its communication with the Chrome browser. There's Gecko driver for Firefox. I'm not sure what Internet Explorer driver or Edge driver is called, but each of them have their own driver that allow you to communicate Selenium commands. So the first thing you need to do, since we're running on our local machine, is go to Chrome. And hopefully everyone has a similar version. You need to figure out, oh, I updated. It updates automatically, which is really annoying. And I'm glad I checked because last time I did this, I had a different Chrome driver. So I'm actually going to have to go through this and show you. Chrome does one-to-one browser version to driver version. Firefox, they'll make a Gecko driver and it'll cover like versions 80 to 82 or something like that. So you have to make sure your driver is the right one to communicate with the browser on your machine. Once you've checked that, we're going to go to the driver download, and I'm going to download this for my Mac computer. If you are following this, I tell you to put it in the documents folder. I'm going to put it in there. If you're following the slides, I'm going to do it slightly differently. Either way, know that it's important to know that your driver and Chrome match. As you can see, I did this 2 days ago, it was 87. I like to show it in the Finder. And what I'm going to do is I have my Selenium project. I created my Selenium project, I believe, on my desktop. Yes. So I'm going to go into Selenium Java. I create a lib library directory and pop it in there. So it's up to you. You can put it in your documents folder or you can put it in your Selenium Java. I'm going to put it in here. It's a zip file. So you double click on it to open it. Now, the funny thing, and it depends on which version of operating system you have, It is what's known as an unsigned executable. Essentially, like the people who developed this didn't submit this to Apple or whoever to say, hey, this is legit software that's not going to break your computer. I believe this happens with newer versions of Mac. They're really locking it down for unsigned executables, but there is a way around it. If you type in this command, sudo spctle master disable, it's sort of like a backdoor special key to make that change to your operating system. So if you run that command, it should ask you for your, I spelled it wrong, spctl. It'll ask you for your password, and you should be able to open Chrome driver once you do that. So you kind of have to force it to open. So what I usually do is right click on it and I open it. And once the driver has been forced open, it'll start working on your machine. So break out 10 minutes, install Chrome driver, put it in a directory, force it open so we can start using it. Once you have Chrome driver installed, that means we have all the tools and the pieces that we need to start communicating with your browser. And we're going to create our first test class to do that. And we'll talk a little bit about the test code that we're making. The first thing you're going to do is go into your project file. And the typical structure for this is you go into source, you go into the test file. This is the main file is where your application code would actually go. And what you need to do is right click on the Java folder. And we're going to do a new package and name it tests. So it'll be in the source folder, Java, new package named tests. Inside of that test file, then we're going to do a new Java class. This is the file structure. It's important because it's where Maven and any other program, anything else that's going to be running your test is going to look for it. Notice at the top, it actually says, okay, we have, when you created the class, it created a class, public class test login. The package it's in, this is the package, is tests. You're going to go to 2.06. This also has your instructions here, right? So it says create a new package called tests. And we're going to copy everything that is here. You can just overwrite what's in there and paste it in. So a quick note about this. This is where sort of POM XML and the things in your test code come together. Notice that we're importing something from JUnit. In POM XML, we had to get the JUnit dependency. Without it, we wouldn't be able to use these classes and methods. We wouldn't be able to do these things. Notice all the Selenium things we have in Chrome options. Without having our Selenium dependencies, we wouldn't be able to use these in our test. One thing that you might see is if you go into your test and you notice one of these things is red, it means you don't have it correctly in your POM XML. But IntelliJ has tools to help you with that. So if you kind of hover over it, you'll see a red light bulb. It says add IntelliJ to dependencies. So now that actually updated the POM XML for you. Another thing you can do is that you don't always have to restart the whole thing. Maven does something called clean. That'll clean everything, rebuild your test code. You should have in your project file, you should be able to see it here, a library or lib file. If you are following the instructions in here, it's going to be slightly different. I think I told you to put it in a different place and name it something different. But the important thing to look at is the code right here that says system set property, comma, you're going to declare that it's Chrome driver. And we need to put the file path to Chrome driver here. So some examples of this could be, I believe I have one in my desktop. One option you could say is if you popped your, it depends where you put it, right? If you put your Chrome driver here, or you put your Chrome driver here, I believe the file path would be So pwd in terminal prints your working directory. It says where you are. Okay, I'm in users, Lindsay Walker. I want to get to desktop. ls, I think of that as list. It lists all the places I can go from here. From my user directory, I can go to desktop. So I'm in users, Lindsay Walker. I'm going to change directory, desktop. So right now, if I type pwd print working directory, I'm in desktop. I'm in my user, Lindsay Walker desktop. Okay, here's my Chrome driver file. I can put the apps, this is called an absolute path because it's how the system would access it. If I set my property like this with the file path right here, it should run when I put in the command Maven mvn clean test, because I have a driver there. Strictly speaking, it is not a test because it doesn't test anything. We'll talk about that in a minute, but it ran my test and it ran it and it's happy about it. Now, your other option, if you put it in library, is to type this in. We're going to replace this, everything above Chrome options. So your file right now looks like this. I'm going to replace system set property. And really all this is two options. It says either look for, if you're on a Windows machine, it's going to look for an executable file. That's the type of file you'd have on a Windows machine. Otherwise, you're on Linux or Mac or something else, it'll look in just for the regular Chrome driver. So here's what I get for copy pasting. Somebody pointed out that in the slide deck, this is inaccurate because the way we set it up, we put it in library. We don't have a drivers directory. So what it should look like instead, this. If you weren't able to follow along with this, 2.05, if you follow the directions in 2.05 and 2.06, you should be able to follow along. The last thing I want to do and show you as sort of the wrap up for today is how to make this actually a test. So if you look at our test code, we have many of the elements that you need to make this actually a test. We have the before annotation. All the things in here are run before any test. We have the after annotation. All the methods and code in here is run after every test. For every test you define, this is a test, you can define more than one of them in the same class. It takes this, it runs it through the before annotation, it then runs the test code, and then it runs it through the after. This is something apparently people forget. Quitting the driver at the end of your test is really important. Otherwise, it's just going to keep running and it'll cause problems. However, this is not a true test because all it does is get the Heroku app. It goes to this page. And we might go a little bit over. So essentially here's what this test is doing. It's saying, all right, get this page. We're going to go here. It says find element by the ID username and send these keys to it. So if you inspect this, you can see that it has an ID of username. Let's send the keys to that. The next thing it does is say, find the element with the ID password. Spoiler alert, this is the element with the ID password. It says send these keys to it. And the last thing it does is find the button and click it. It has something in its CSS that is called a button. It's a button, that's what it is. It's a CSS button, and it clicks it. This is not a test. Why is this not a test? It doesn't check to see if anything happened. All it does is tell you to do it. To make this a true test, you need to add in what is called an assertion. I have to update that as well. So all you need to do is go into 2.07, copy the code, and add it at the very end. Essentially, it's saying it's looking for this element called flash success. This thing is called, its class is called flash success, saying, is it there? And that's a test. Now, when you run the command, it is actually running a real test, not just doing some things on the page. And if you run it, you should actually see, so the way you run it, and it's also listed in module 2 here, this video shows you how to run a test and another option. So you can clean it, you can test it, and when you run the test, you should actually see it's accessing the Chrome driver on your machine and doing these things, and it'll tell you if it's a success. I suggest that you try a failure. It's important to say, all right, this thing doesn't exist on the page. If I run this, my test should not tell me that I passed. Right? If I change what I'm looking for on the page, it's looking for that green thing. It should tell me something is wrong.